So yes, I'm going to be talking about a project that's been going on for quite a few years. And it's all about taking a physics-based simulation code that was developed in the plasma group here at Imperial and making it operational. So yeah, just want to say that I've included the Gorgon Ops team, which is what we're calling this operational code. And the Gorgon Ops team very much is including the RCS team, who's done a huge amount of work, both from that free support that Diego was mentioning and actual paid for support. So very briefly, a very quick primer. What are we doing? We're trying to model everything from the sun to the mud in this problem. So space weather is looking at our space environment around us all the time in real time versus space climate, things like that. And we want to be able to make forecasts of this environment and push that through to end users. End users in this case include satellite operators, power utilities, the aviation sector. It's a wide-reaching problem with very many different affected industries. In the UK, it's part of our National Risk Register, and that has driven a lot of these developments over the last few years. What we're doing more explicitly, we are solving a magnetohydrodynamic system, and we have two different regimes that's around the Earth. So we set up a kind of a big box around the Earth with a dipole in it. This dipole maps down to the ionosphere. So last year and this year as well, we've seen some fantastic aurora. That is all the ground footprint of what we would call space weather. So there is a legacy code, Fortran, which has been developed and has a lot of science behind it. And one of the challenges here is to turn this into something operational. So scaring you with a slide with a lot of text, the real take-homes here is that we have an entire forecasting suite. We have that base physics engine, the Fortran code we're talking about. And the challenge here is to run that code faster than real time on as little compute as possible and provide whatever inference we need for those end users. So there's a whole Python package associated with this, with a lot of input from the RCS team that has been developed over the last while. And we are running this on multiple systems. So not just the Imperial system, we're running it at the Met Office on the Monsoon HPC, and right now working to get that on the Parallel and operational suites. We're also running it in ESA. So yeah, a whole bunch of different deployments, and that's all made available by the software support that we have had. I'm just going to touch on two of these projects. I realize this is a lightning talk, so really getting through this quite quickly. The first is obviously our deployment with the Met Office. So that is something that has been part of the SWIMMR program. Interesting acronym, but the real take home here is that with the SAGE aspects of the SWIMMR program, we are providing utilities such as power, rail, and gas utilities in the UK with real-time forecasting of the space weather environment. So collaborations there across a whole bunch of UK institutes. And then finally, what is currently being deployed is the ESA BIGG project. So that is a collaboration with Bergen, where we are doing the same kind of modeling, but also for satellite operators and providing them contextual forecasts. And that is going live imminently. Into some of the technical details, there's some interesting challenges operationally, particularly running real time all the time on an HPC system. So we've made use of a whole bunch of different technologies, including in the Met Office case, AWS as a kind of a glue to bind it all together through different models. So we provide inputs to downstream models that then go through to the end users, and scripts that's pulled from an API, run in real time on Monsoon, so that's the HPC, and then package through. And I just wanted to show this very briefly, just to get an idea about what we actually are producing. So we produce pretty pictures, firstly, for contextual information, but we also produce ground magnetic field forecasts, and that translates into currents in the power grid, which could lead to blackouts in the case of extreme sort of solar storms. And some of you may have remembered towards, what was that? That was May, but also in October, there was some lovely aurora over London. Adrian Lamore, who's the other postdoc working on this project, took this over Hammersmith Bridge, so that's fantastic. But what that actually means for us in terms of Gorgon Ops is, yeah, exactly what we see here. So we were running in real time, providing these forecasts of, let's see if we can see that, yeah, the power network over the UK, where GICs, so these are these currents that are flowing in the system, where they are peaking, and additionally, that's a contextual forecast of what our magnetosphere environment looks like. I'll just end on this. So that's the current deployment with ESA, so that's the big project. And again, using a whole bunch of different tools. We have our own API for real-time solar wind input, so that's our input feed into the model that we are hosting, and then providing outputs through Azure in this particular case to Bergen, but also to partners here at Imperial. So thank you.